Hello everyone and welcome back to our videos. Today our video will talk about the anti-skid system components and we will illustrate the function of every component of the anti-skid system. The anti-skid system consists of three basic components: wheel speed sensors, an anti-skid computer, and the last one, control valves. And if you see this figure, you find that this our sensor, the wheel speed sensor, and here we have the anti-skid computer or control unit, and here we have the control valves. We begin with the wheel speed sensors. There are two types of systems in use with the wheel speed sensor: an AC system, and that means an alternating current system. It will goes through the sensor, and the second one, a DC system, or we said direct current, and we have a direct current goes through the speed or the wheel speed sensor. They are essentially alike except for wheel speed sensors and one circuit in the control unit. The AC sensor is a variable reluctance AC generator in the axle of landing gear that uses a permanent magnet surrounded by a pickup coil. The alternating current wheel speed sensor creates a variable frequency alternating current. The control unit converts the varying frequency alternating current into a direct current signal voltage that is proportional to the frequency of the alternating current. The DC sensor or direct current is essentially a small permanent magnet direct current generator, which produces a voltage output directly proportional to the rotational speed of its armature. The second component of the anti-skid system is the control valves. A 3-port anti-skid control valve is located in the pressure line between the brake valve and the brake cylinder, with the third line connecting the control valve to the system return manifold. When a wheel begins to decelerate fast enough to cause a skid, the control unit detects the changing output voltage of the wheel speed sensor. The control unit sends a direct signal to the control valve, which closes off the pressure port and opens the passage between the brake and the system returns. So if we focus here, we find the basic function of the control valve is a close off the pressure port and opens the passage between the brake and the system return. In the figure 1, we see here a direct current signal from the control unit energizes the coil on the armature of the flapper valve. This is the flapper valve, and the current from the armature tool goes to here. And the movement of the flapper changes the pressure drop across the fixed orifice. So if there is a direct current, or signals, it will move to the flapper valve. The flapper valve, it will goes down or goes up. When the flapper is centered between the nozzles, the pressure drops across orifice 1 and orifice 2 are equal. as we see here. When the flapper goes to the center of the nozzles, the O1 orifice 1 and O2 orifice 2, the pressure will be equal, resulting in output pressure P1 equal to P2, as we see in this figure. The pressure here in P1 and P2 it will be equal because the flapper centered the nozzles. But when the armature of the flapper valve is energized, the flapper moves over and restricts the flow through orifice O1 while increasing it through O2. So when the flapper is energized, as we see in this figure 1, the flow or the pressure it will restrict on the orifice 2. That means the increased pressure drop across O2 causes P1 to be greater than P2. So when this restricts the pressure on the on the orifice 2, the pressure on orifice 1 it will increases. The last component of the anti-skid system is the control unit or the control computer. The control unit has three main functions. The first function to generate electrical signals usable by the control valve. The second function to regulate brake pressure to prevent a skid during landing deceleration. And the last function to prevent application of brake pressure prior to touchdown. So these three functions of the control unit or the control computer. The locked wheel detector receives a signal from the squat switch, which indicates whether the aircraft is airborne or on the ground. As we see in here in this figure, we have a squat switch. This squat switch is used to indicate that the aircraft is airborne or on the ground. That's the function of the squat switch. If airborne, the circuitry prevents the brakes from being applied before touchdown. So that's if the aircraft on the airborne. What about if the aircraft on touchdown? When the aircraft on touchdown, the squat switch removes the ground from the locked wheel arming circuit, and the wheel speed sensor generates a signal which allows the control valve to send full pressure to the brakes, as we see in this figure. When the squat switch senses that the aircraft on ground, the squat switch it will remove from the ground, and that will let the wheel speed sensor to send signal to the lock wheel detector, and from the lock wheel detector it will go to the amplifier for increase the amplitude, and after that the control valve will give full pressure to the brake. When the airplane is on the ground and the wheels are rotating at more than 20 miles per hour, who will give this detection? The sensor of the anti-skid system. The skid detector and the modulator provide almost all of the anti-skid control, as we see here in this figure. The detector or the locked wheel detector will send to the control valve for indicate that or to provide that almost all the skid control, the anti-skid control. When the airplane is on the ground and all three wheels are rotating less than 20 miles per hour, and as we said, who will detect the rotating of the wheel? The sensor of the anti-skid system. The locked wheel arming circuit is inoperative and the pilot has full brake control for low speed taxiing and parking. After we understand the component of the anti-skid system and every component how it works, now we will talk about the system test. The anti-skid system have two ways for test, on ground and on a flight. And I'm gonna start to talk about the ground test. We have some procedures to follow. The pilot turns on the anti-skid control switch from the cockpit and presses the brake pedal. Both the left and right brake lights should illuminate. The pilot presses the test switch and holds it for a few seconds. The lights should remain on. When the test switch is released, the two brake lights should go out and stay out for a couple of seconds, then come on. When these things happen, so that means the anti-skid system is work. What about the flight test? With the airplane configured for landing, the pilot depresses the brake pedals. The brake lights should remain off. Why? Because the landing gear is retracted. The pilot then presses the test switch, which should illuminate the brake lights for as long as the switch is held down. The test switch sends a signal through the wheel speed sensors, simulating a wheel speed greater than 20 miles per hour. That means our system is satisfactory work.